Good morning friends. In the previous class we covered problems 3.1, 3.2. Next problem is 3.3. In this problem from textbook, 3 resistors 1 ohm, 2 ohm, 3 ohm are connected in series. But underline the question, important points in the question. Underline the part of the question which is important. Data, they are in series or parallel, this point. And EMF of 12 volts. What are the internal resistance? Internal resistance is negative. If they don't give internal resistance, they mention potential difference. Direct potential difference means you negate the internal resistance, use the data. We only wait to take instead of E. So whenever the internal resistance is not there, negligible means approximately 0. Then internal resistance is not there means E and V are same. Internal resistance 0 means terminal potential difference V and EMF are equivalent for the cell. That means total voltage. Find equivalent resistance of the combination. Equivalent resistance or resultant resistance meaning is same. And find potential difference. Potential drop they may call or voltage across also they may call across each resistor. Series connected diagram not required for the examination for P3 purposes. If you draw it sketch it is always better. What is common for the series combination is current is same. Parallel combination voltage is same. Series combination current is same. So current is same for I is positive to R1, R2, R3. Then voltage across R1 is I into R1 is V1 and voltage across R2 is V2. V2 is equals to I into R2. Voltage across R3 is nothing but equal to V3. V3 is equals to I into R3. So first find out the equivalent resistance also and find the current and then find the voltage across each resistor. For current also we need to find out. Direct voltage division method is there. V1 is equals to V into R1 by R1 plus R2 plus R3. Direct formula is there for the competitive exams. Don't use that formula here. Use it for theory examination. Don't use that. Our data I am writing R1 is equals to 1 ohms, R2 is 2 ohms, R3 is 3 ohms. They are in series. And EMF is 12 volts. Internal resistance of the cell is approximately equal to 0. This is for the cell. This is for the cell. Next, equivalent resistance. Series combination equivalent resistance R1 plus R2 plus R3. Resultant or equivalent. Resultant resistance or series resistance. Resultant of series resistors or resistance combination is R series equal to R1 plus R2 plus R3, which is equals to 1 plus 2 plus 3, which is 6 ohms. So resultant resistance is 6 ohms. Important for final result, better take in the boxes on this. I underline it, highlight it. So first, generally get correction purpose, no, they just go for the answers, main points. That will be easy for the corrections. Not compulsory, but if you highlight that or take in the box is always better or underline it. Next, this is the first part. Next, you have to find out current. Equivalent resistance. This is equal single resistance. It is. Diagram is not required. This is R series connected to the battery of EMF R0. EMF is 12 volts. Current is 9. So EMF is equals to this voltage across this is V, not required. E is equals to I into R plus R combinations. But small r is 0. So what you get is E equal to I into R. I is R equivalent, is R series resultant. So current I is equals to E by R series. Directly generate the relation also R series, which is nothing but equal to 12 by series resistance 36. Our current is equals to 2 amperes. Current is same in all resistors. In each resistor. Current is same for series resistance or resistors in series. For resistors in series. So next, leakage. What is the voltage? This is the second part of the IA bit. It's current now. Next, voltage across R1 or potential drop across R1 or potential difference also we can take. Potential drop across R1 is V1 is equals to I into R1. V1 is equals to current is 2 amperes, R1 is 1 ohm, which is equals to 2 volts. Is V1 minus 1. Similarly, voltage across R2. R2 is V2 is equals to I into R2, which is 2 into 2, which is 4 volts. This is V2. Next, voltage across R3. Voltage across R3 is V3 is equals to I into R3, 2 into 3, which is 6 volts. 6 volts. You can verify this total voltage is supposed to be equal to sum of the voltages V1 plus V2 plus V3 is supposed to be equal to E. Interface is not there, otherwise they are not equivalent. So all you have to get the relation. 6 plus 4, 10, 10 plus 2 is 12. If interface is given, then they are not equivalent. Then how they are equivalent is V is equals to this V. This is a V. V is equals to I into Rs. Total voltage V is supposed to be equal to I into Rs relationship. You will get R. If you require the relationship, E is equals to V plus I into internal resistance. This is the relationship. Internal resistance, if it is 0, we are not taking this. Otherwise, it will be equal. This also we can take the relationship. From this you get the V, total voltage. This is the total voltage. V is supposed to be equal to V1 plus V2 plus V3. This is not required. That is only for your verification purposes. Up to this only. 3.4. One of these problems is important with small variation they may give, but these problems are very important. Series and a parallel combination of the resistors. 3 resistors, 2, 4, 5 ohms. 3 resistors, 2 ohm, 4 ohms, 5 ohms are in parallel, are connected in parallel to the battery of potential difference or EMF over 20 volts are connected. In parallel to the battery of EMF 20 volts. Battery of EMF 20 volts and negligible interresistance and negligible internal resistance. Negligible internal resistance. You have to find equivalent resistance and current through each resistor and total current through the battery. A bit. Find equivalent or resultant resistance. B bit. Current through each branch or each resistance. Each resistor. Current through each resistor and current through battery. This is also called the main current. Total current or main current. This is nothing but total current. Answer. First write the data. Resistors R1 is equals to 2 ohms, R2 is equals to 4 ohms, R3 is equals to 5 ohms. They are in parallel. Next is cell EMF. EMF is 20 volts. Inter resistance is approximately 0 negative. This is for the cell or battery. Right. Next, they are amplified or resultant you have to find out. This is R1. Current through this is I1. This is R2. Current through this is I2. This is R3. Current through this is I2. This is cell. EMF is 20 volts. Internal resistance is 0. I1, I2, main current, total current is I. That is the current possible to that. Main current is I. Parallel combination resistance is 1 by R parallel is equals to 1 by R1 plus 1 by R2 plus 1 by R3. Only 2 are there, means these directly can go for R1, R2 by R1 plus R2 you can take. But 3 are there and more are there, means you take a basic equation of the parallel resistance. Resultant of parallel. This RP is resultant of parallel resultant resistance of parallel combination. One by R parallel is equals to 1 by R1 plus 1 by R2 plus 1 by R2. Substitute the values. These are the first part of the question, that is 8. So 1 by R parallel is equals to 1 by R1. R1 is 2 ohms. 1 by R2 4 ohms. 1 by R3 5 ohms. Take the same for the right side of the equation. So I can take 20. 2 tens are 4 5s are 5 4s are is 1 by R. Reverse your it is nothing but equal to 9 plus 10 19 by 20. So but reverse it, many students do a mistake here. They simply take RP is equal to 90 by 20. No, it is a reciprocal, reverse is there. So RP means again both right side also have to reverse. So resultant resistance is therefore RP is equals to 20 by 19 ohms. 1 point something you can get that we calculate and right. Okay, this is the resistance for the equivalent resistance. Next is B bit. For parallel combination, what is saying is V is same. When interresistance is 0, V and E are equal on this. Interresistance 0 means E and V are same. Okay. So first to find out the equivalent resistance we got, then the current you have to find out. The current divided into each parts and equivalent the voltage across the combination also we can find out. So equivalent circuit if you are taking in the examination, equivalent circuit actually not required, but if you draw it is always comfortable. This is a parallel resultant. Okay, this is a cell of EMF T, resistance R equal to 0. This is 20 volts. Current is I. Voltage across the combination is V. V is equals to I into RP is a and we have to find out first V also we can find out or I also we can find out. What is the relation we can take is E is equals to I into R plus R. We already got this RP. Small r is 0. So we can find out the current from that. So total EMF, cell EMF E is equals to I into R parallel plus internal resistance. But small r is 0. So we can get only for current. Therefore current, total current through battery is actually given as the third one. Is given as third one. here. Battery. I'll take as C. Battery. So I is equals to E by R parallel. EMF is nothing but equal to 20 by R parallel is 20 by 90. This is I total. Is nothing but equal to 20 cancels, no, 90 amperes. This is through battery. This is also called as main current. Total battery total or main current is this much. Potential difference across the combination is V. V becoming reverse. Potential difference across the combination V equal to constant for parallel resistors. The resistors are parallel. Potential difference across the combination V equal to constant for parallel resistors. This is for parallel resistors. Getting the relationship E is equals to two methods. If V equal to I into R by also we can take or E equal to V plus I into R also we can. From this also we can find out V. This I total current R is 0. So if this part is not required, so E becomes equal to V because internal resistance is 0. So we can take this, but R equal to 0. This part is 0. Therefore V is equals to V equal to 20 volts. This is equal to 20 volts. V is same. Then you can find out the current and voltage. You can follow this method, or you can also follow the relation as or V equal to I into R parallel. So we can take I already found out into R parallel. So you can find out from that also you get the V relationship. But don't need to take both methods in the examination. Take only one method. So I into RP. How much is I current? Current we got is equals to 19 amperes. What is the resistance RP? Is 20 by 90. 90 cancels. What you get is V equal to 20 volts. Which is supposed to be equal to EMF, right? Because internal resistance is 0. This part is extra I will give, not required. Next part is voltage across each resistance, current through each branch of the resistance. That is V which. V current to R1 electrode. V is same. V equal to I1 R1. V is equals to I2 R2. That condition here. V is same for all resistors. So current through R1 is I1. V equal to I1 R1. V is also equal to I2 R2. One step, not compulsory, grade separate steps. I2 R2. V is also equal to I3 R3. V is also equal to I into R equivalent. So first part if you take current through R1. R1 is I1. V is equals to V by R1. How much it is? V is 20 by R1. R1 is nothing but equal to 2 ohms. 2. So I1 becomes equal to 10 amperes. We get the units also. Next, through R2. I2 is equals to V by R2, which is nothing but equal to 20 by R2. R2 is 4 ohms, which is nothing but equal to 5 amperes. Next, through R3. I3 equal to V by R3, 20 by 5, which is equals to 4 amperes. Here, I3 equal to 4 amperes is the result. Addition we can check up. I is supposed to be equal to verification only. I total is supposed to be equal to I1 plus I2 plus I3. I1 is how much is 10. 10 plus 5 plus 4, 19 amperes. We already got the total to 19 amperes. This equals to 19 amperes. This is only for verification purpose. Or else if you separately calculate V calculator, first we calculate V and then V equal to E relationship. So you get the V already here. Once you get the V, we can calculate V is equals to I1 R1, V equal to I2 R2, we can calculate I1 I2 I3, and at the end we can calculate total current. So see which we can do this later also. First you can do this also you can do later. That is going to be good choice. Next resistance problem is 3.5. At room temperature 27 degrees centigrade, the resistance of the heating element is heating element. Element is a word used for many cases in the different ways. Here element means a piece of the conductor, small part of the conductor is called as an element. Filament for the bulbs. Element is used for the electric stoves, electric wire only. It is nothing but electric wire in the form of a coil which is getting heated up and produce the heat for us. So electric stoves, what are water heaters, inside the water heaters, wire is there. That is micro wire is used. That is called as an element. Element means small part of the conductor here in this case. Not a chemical element and periodic table. Don't think that way. You have to think this as a small part of the conductor element. At room temperature 27 degrees Celsius, that is initial temperature. The resistance of the heating element is 100 ohms. What is the temperature of the element if the resistance is found to be 117 ohms? Given that the temperature coefficient of the metal of the resistor is 1.7 into 10 to the power of minus 4 per degree centigrade. You have to find out the temperature, new temperature or final temperature when the final resistance is given. The room temperature is given, initial temperature. T1 is 27 degrees centigrade. That is initial temperature. And directly writing the data. 27.0 is given, that is for the least count relationship. Centigrade. Initial temperature. Decimal is there, means you can take it as 27 degrees centigrade. Heating element is 100 ohms. R1. T2 we have to find out new temperature. R1 is at T1. R1 is equals to 100 ohms at temperature T1. R2 is equals to 117 ohms at T2. Alpha, temperature coefficient of resistance or resistivity, is 1.70 into 10 to the power of minus 4 per degree centigrade or per Kelvin, one and the same because it is related to temperature difference. Find T. Initial temperature is given, final resistance is given, that initial temperature is given, final temperature given. What is the relation we have is R2 is equals to R1 into 1 plus alpha into T2 minus T1 into delta T average. Delta T itself is temperature difference. Delta T is equals to T2 minus T1. R2 is equals to final resistance is initial resistance R1 into 1 plus alpha into T2 minus T1. But I gave you the relationship in theory, what I gave is first beginning RT equal to R0 into 1 plus alpha T only. T2 minus T1 initial temperature is 0 degrees centigrade. 0 degrees centigrade means T1 is 0. So R1 becomes equal to R0. Okay. But that is actually exact relationship. This is an approximate relationship, but this only you have to use for the theory examinations. That most of the market exams as well. So T2 minus T1. First to find out the delta T, then you go for finding of T2. In this case, this is the data. Okay. Answer I am part of it, I am giving just that. R equal to R1 times. So 1 plus alpha T. Alpha is given for you. R2 R1 is given. Delta T you have to find out. So expand this, what you get R2 equal to R1 plus. If you remember directly for alpha, that is better actually. So R1 plus R1 plus R1 alpha into delta T. This R1 taken to the left side becomes R2 minus R1 by alpha. So we can get the relation. If you remember direct relationship, that also can go. Alpha is equals to R2 minus R1 by R1 into delta T. R1 taken to the left side becomes equal to R2 minus R1. This also I gave you the relation before in theory. While taking theory points. R1 comes here into that comes in the denominator into delta T. Delta T we have to take temperature difference. Delta T is nothing but equal to R2 minus R1 by R1 into alpha. Such the values. This becomes equal to temperature difference. Temperature change. Delta T is equals to R2 is 117. 117 minus R1 is 100 by R1 is 100 into alpha 1.70 into 10 to the power of minus 4. So delta T is nothing but equal to T2 minus T1. Delta T is nothing but equal to 117 minus 100 is 17 by, we have decimal relationship. Take no, this is going to be 170 into 10 to the power of minus 4. And these two, change the decimal here, it becomes equal to 10 to the power of minus 4 plus 2 is minus 2 units. So 1.7 into 10 to the power of minus 2. Take it to the numerator. This decimal also if you remove, it becomes equal to minus 3. 17 cancels. What you get is 1000 degrees centigrade is the temperature difference. Temperature difference delta T is T2 minus T1 is 1000. You have to find out our T2, therefore final temperature. T2 is equals to 1000 plus T1. 1000 plus T1 is 27 degrees centigrade, which is 1027 degrees centigrade is the answer. 1027 degrees centigrade. If you require the decimal relation, please call me now. You can take even 0.6. Next question. Negligibly small current is passing through a wire of length 15 meters and uniform cross sectional area 6 into 10 to the power of minus 7 square meters. Resistance is measured to be 5 ohms. What is the resistive material? 3.6. In this 3.6, you are given the data. Length of the wire, meter wire. L is equals to 15 meters. And area of cross section is 6.0 into 10 to the power of minus 7 square meters. And resistance is 5.0 ohms. You are asked to find out resistivity equal to how much. The relation we have is R equal to rho into L by A. A is area of cross section. You have to find out rho. This is resistivity. Rho is equals to R into A by L. Sometimes they give the radius instead of area. Area equal to pi r square relation. So rho is equals to resistance is 5. Area of substance 6 into 10 to the power of minus 7 by 15. 5 3s are 3 2s are. So resistivity is 2 into 10 to the power of minus 7 ohm meters. And conductor or insulator they will ask you. Negative is there means resistivity is very low means supposed to be conductor. Plus value is there 10 to the power of positive values are that means here power that is supposed to be insulators. 10 to the power of plus 6 plus 8 insulators. 16 also positive means insulators. So negative is there means a very low value of resistivity means conductor. Okay, stop now.